Hello, 7th grade scientists. Today we're going to be doing Measurement B, our scientific measurement skills for volume again, but this time instead of liquids, we're going to be measuring the volume of solids. And so let me introduce the materials and tools that you'll be using first of all. Okay, we'll be using this little solid aluminum block, so each one of you, or each group or partner group, will have one of these. Okay, you will have a plastic container like this, or like this, or like this. Okay, you will also be using a metric ruler. You will use water. Again, we don't have to use any kind of special water. We're just going to use tap water. We will be using graduated cylinders again. You remember these from the last time. We might even use the really small ones. And you will have some marbles that you'll be using to measure the volume. All right, so let's begin by looking at the questions. Let me do this. Okay, so the questions and observations that we will discuss in a little mini lesson before we get started with the procedure on this one are the following. First of all, solid objects have a volume also. What is volume? Well, volume is simply the same for solids as it is for liquids. It's the amount of space that something takes up. So we have a formula for symmetrical objects. Now this would be a symmetrical object. We can actually measure the length of each side. It's very even, and that's why it's called symmetrical. So the formula for finding the volume of a symmetrical object, because we can measure each side, the length of each side, it's very easy. Its volume is equal to the length times the width times the height. So you'll be using that formula a little bit. Number 3, what's unique about the unit of measurement for volume when the length of all sides is measured in centimeters? All right, so I want to refer back to the first Measurement A lab video that you watched and remind you that in volume, because it's the amount of space that something takes up, volume is three-dimensional. Volume is three-dimensional. It's cubic. So that means that if you measure all the sides in centimeters and you multiply length times width times height, you are multiplying centimeters times centimeters times centimeters. So your answer is going to be in cubic centimeters. It's very important that you use centimeters as your unit of measurement for length, because remember, I also told you that 1 milliliter is equal to 1 cubic centimeter. So that will make comparing volumes with that you do with a graduated cylinder very easy. It's very easy to compare it to volume when you do a symmetrical object with a metric ruler, because 1 milliliter is equal to 1 cubic centimeter. All right, and then the last question is, can the volume of an irregular shape, I'm going to change that. In fact, I'll change it right now. Can the volume of an irregular shape object be measured? And I mentioned, I think, in class, but I'm going to talk to you about it again, and that's going to be our mini lesson before we actually start on in class the next time on this lab, is the displacement method. So I'll just give you a really brief overview again. So with displacement, using this technique, the displacement technique, what you're doing is you're measuring how much water or liquid is displaced or replaced by the object. Okay? So the displacement method is to put in any amount of water in your graduated cylinder. It really doesn't matter how much you start with, as long as it can be measured by the graduated cylinder, as long as you measure it accurately. So you put in a certain amount of liquid in your graduated cylinder, you measure, record that initial volume, and then you put the object that you want to measure the volume for into the water. And then you measure the volume again, you measure the new volume. then the volume of this object, in this case the marble, is going to be the original volume measurement when it was just water, and then you subtract that from the new volume measurement of the water and the marble. So we will practice that in class before you get started with the procedure, so don't worry. But that is the displacement technique for measuring volume. Okay, and then your procedure, I want to run through it really quickly. You're going to use the metric ruler to measure the length, width, and height of your block that you have. And you always in science want to record any data or observations that you gather. So make sure that you copy this lab report and put it into your science assignment folder. All right, and then you're going to calculate the volume of the block, and again we're going to use that formula that I spoke about earlier. Excuse me. Another thing you're going to do is you're going to play around with the volume of these plastic containers. So if your plastic container looks like this, it's going to be pretty easy to measure the length, width, and depth. If it's circular, you're going to have to figure out another formula for calculating volume. You remember when we talked about in the other lab video that the area of the base times the height. So you're going to use a different formula for volume on this one. So you're going to try to figure out what the volume of this container is by using the metric ruler, and then you're going to fill that same container with water, and you're going to measure the water that went into it in a beaker or a graduated cylinder. So you're going to have the volume of the container from two different perspectives, and we're going to compare that and see how close you came to being accurate, how close you were to the right answer. Okay, and then step number 5 in the procedure, you're going to use the water displacement technique. Remember, again, I'm going to go over that. Mr. Johnson's going to go over how to do that displacement technique before you get started. So you should feel pretty confident in doing that. You're going to measure the volume of 3 marbles at one time and then calculate how much one marble's volume is going to be. And then you're going to redo that procedural step with just 1 marble. All right, and so you'll be using the displacement technique a little bit. Then once you've done the procedure, you and your group will sit down and talk about these conclusion questions. You will try to answer them together. You can work together. You can ask for my help, and we're going to go over it as well. And then you're going to pair up with another group, similar to what you did after Measurement A Lab, and you guys are going to compare your findings and see if you answered the questions the same way, and then you're going to write a summary of everything that you discussed. So I hope that you enjoyed this lab and learning how to measure volume again, and I'll see you in class. Thanks.